Good morning, Sarah Redskin Calculates. Here we are. We are now talking about the washer method. It's related to what we talked about last Friday with the disk method. And it's related to calculating the area between two curves. So what we're going to essentially be doing is something similar to that, and then just rotating two curves around the x-axis. So right now we're going to find the volume of the solid formed by revolving the region bounded by the graphs of y equals square root of x and y equals x squared. So let's see what those might end up looking like. So I'm going to scooch it up a little bit here. And here's my x and my y. So the square root of x, when x is 0, y is 0. When x is 1, y is 1. When x is 4, y is 2. So I know I should do this another color. I should do this color. Same color as the graph. So our radical x ends up looking like this. Okay, so that's my y, the first y. The other one is y equals x squared. All right, but that goes the other direction. That will also, when x equals 0, y equals 0. And when y equals 1, x equals 1. But it's going to keep, it's an exponential, so it's going to keep going up like this. All right? So we want to find out the volume of the solid formed by revolving these around. So what we're going to be doing is taking this, right, if this is my infinitesimally thin rectangle, and revolving it around the x-axis, then I would have, well, I'd have this shape, right? And the next thing I'll do is, oops, I switched colors there. The next thing I'll do is take this area, or this distance, I should say. So this distance, and when I subtract the pink distance here from the green distance here, so the pink distance minus the green distance, it leaves me with just this distance. So I'm revolving two things around the x-axis, but when I take their difference, I'm getting a kind of a different shape. So besides right here on the origin rather, I am making a washer shape. So when I spin, let's see, I'll go back to my other color, white. So when I spin this piece around the x-axis, it leaves a hole in the middle, and it kind of looks like a washer. If you know what a washer looks like, let me try to draw a three-dimensional picture of a washer. This is a pretty thick washer, but a washer has a hole right in the middle, and that hole is where the x-axis is coming out of, okay? So that's what we're doing in revolving this. So in the textbook, they talk about your big R. This is big R of x. Remember, the R stands for radius, and this curve is little r of x. The reason that this is big R of x is because in revolving, the section where they are revolving has to do with this curve being on top. The green curve is on the bottom, so that's why that is called little r of x. All right, so let's stop right there. All right, so we've agreed that big R of x is the square root of x because it is above x squared in between 0 and 1 where they intersect, okay? So what we're looking at doing here is from 0 to 1, don't forget to multiply by pi r squared. But my r squared is going to be the big R of x minus the little r of x. So that's squared. And the height of each one of these washers is my dx on my axis from over here, okay? So my dx goes this way. So that's what we're looking at. So let's make our substitutions. Whoops, actually that won't work, will it? What did I do? I squared the whole thing. I can't take their difference and square them. I've got to square this one and then also square this one. So let me make that quick adjustment. This is just like being in the classroom, isn't it? Watching Noldy make a mistake. So this would be r of x squared minus, we're going to subtract little r of x squared, and then that whole chunk gets multiplied by dx. All right, so far so good? So make your substitutions, and remember you can type you can actually type this into a graphing calculator. Well, not this part, the next part. So here we go, from 0 to 1, big R of x is the square root of x squared minus x squared and that whole thing multiplied by the width of every one of the infinitesimally thin washers that are being spun around the x-axis. All right, so here we go. This is the part that if you typed it into your graphing calculator, you would get a value for. But since it's a calculus class, we'll keep working this out. Square root of x times the square root of x is x. X squared is x to the fourth. Then we would end up taking the antiderivative, which ends up being 1/2 times x squared minus 1/5 times x to the fifth. And we're evaluating that from 0 to 1. So when I substitute a 1 in place of this, usually at this point in time, I would say just type this into your calculator. Or maybe you would write it out this way. 1 squared minus 1/5 times 1 to the fifth minus 0, right? So I'd have minus 0 minus 0. I think we all recognize that. So here I'd have 1/2 times 1. 1/2 times 1 and 1/5 times 1. So that would give me pi times 1/2 minus 1/5. And that would give me what? Pi, I don't even know why I'm doing this, but that would be what? 2/10 minus 2/10 minus, let me get a common denominator. Well, nope, that would be 5/10. Boy, oh boy. Can tell it's a Monday here. So, 5/10, sorry about that. Minus 2/10, which would give you 3/10. So, in your calculator, if you wanted the exact answer, you'd have you'd have 3 pi over 10, but in your calculator, you'd have 3 times pi divided by 10, and that would be, the decimal approximation for that would be, I can figure that out real quick for us, divided by 10. So that would, is about, in your graphing calculator, would give you a 0.942. All right. So there you go. That's using the washer method. And in order to use it, it requires knowledge of the disk method. So you're taking one big disk and subtracting a smaller disk, which makes it look like a washer, and that's why it's called the washer method. But it's all in the same section on volume because it's related. So anyway. Hopefully that helps you out a little bit. And I will talk to you later. Everybody have a great Redskin day.